everyone, this is Shweta. Today I am going to explain you about the CMOS inverter. For that, open the Cadence Virtuoso tool and click on this terminal, and here the dialog box appears, and here you need to type Virtuoso ampersand and click on OK. Now the Cadence Virtuoso tool will be opens. And now go to file, here new, and click on this library and give the library name. So I am giving the library name and E9, and here the technology file should be attached to an existing technology library, and click on apply, and here the technology library should be selected, that is of GPDK90, and click on apply and OK. So it shows that the technology library has been successfully attached to the GPDK90 technology. And now again go to file, click on new, click on the cell view, and now we need to select the library name which was given now. So that is E9, and I am giving the cell as CMOS inverter, and the weave should be schematic and the type should be also schematic, and click on OK. Now the schematic window will be appears. So for the CMOS inverter we require one NMOS and one PMOS. So for that click on this create instance and click on this browse button, and here the library should be selected as GPDK90 technology, and here the cell should be PMOS should be selected, and here the symbol we need to click on the symbol and close and hide and place this NMOS in the schematic window. And next same for the NMOS. So here the library is GPDK90, so just change the cell as NMOS and place in the schematic window, and now give the connecting wires over here. So the gate terminals of PMOS and NMOS should be connected, and the drain terminals of PMOS and NMOS should be connected, and the source terminals of PMOS and the body terminal should be shorted. So in this way we need to short the PMOS source terminal and the body terminal, and same for the NMOS. So the NMOS source terminal and the body terminal should be shorted. Now we need to give the VDD and VSS. For that click on the library and go for the analog library. Now here we need to select the VDD and click on hide. So here we need to give the VDD same as ground. So in the analog library only we need to change the cell name as ground. So we need to place the ground over here, and for that also the power supply should be also given. So again we need to go to analog library, and here VDD, close and hide, and here again in the analog library, so we need to type as VDC and give the VDC over here. It means the power supply. Actually it is not properly connected, so we need to connect it properly. Just select the VDD and drag over here, and same for the ground. So we need to give the ground, and for this we need to give the connecting wire. So after that we need to give the input. So for the input in the analog library just type as V pulse. So we need to give the V pulse, and it should the another terminal should be connected to the ground. And this terminal should be connected to the inputs gate terminals, and here we need to take the output and we need to create the pins for it. So for the input we need to give as V in and click on hide, and for the output we need to also give the direction as output, and we need to give the pin names as V out and click on hide and apply, and here the V in should be connected. Now click on Q, click on this one and click on Q, and we need to give the inputs and we need to give the voltage also. So for that I am giving the voltage as 1.2 for the GPDK90 technology, and the period is 20 nanoseconds and the pulse width is of 10 nanoseconds, and click on apply and OK, and here the voltage should also given. So this is the power supply, so click on that one and give the DC voltage as 1.2 and click on apply and OK. So now we need to check and save. So click on this check and save. So it shows the if any errors are present, it shows the errors. If there is no errors, then it also shows there are no errors. So click on it. So for me it is showing as no errors, so I can proceed for the waveforms. So click on the launch ADEL. Next here in the analysis choose, so choose the analysis as transient analysis, and here give the stop time. I am giving stop time as 100 nanoseconds and click on this moderate, and after clicking on this moderate, click on this enabled and click on apply and OK. Next here set up outputs, click on this, and from schematic you need to select the inputs and outputs as well. So click on the schematic. So this is the V in and this is the V out. So after selecting the inputs and outputs, now click on this run button. So here the status is showing as successful. After that we'll be seeing the waveforms. So right click on it and click on this split current strip and click on trace. So the inputs and outputs will be separated, and here in the V in right click and increase the width as thick, and here same for the output, click on right click width as thick. So here the CMOS inverter, so as the input is 1 then the output is 0. So in this way CMOS inverts the input and the output. So this is the Cadence Virtuoso tool, the CMOS inverter. And if you like my video, please subscribe, like, share and subscribe. Thank you.